Yeah, so good morning.
Good morning, sir.
Yeah, so before we start, I'd like to ask you maybe whenever you are not talking, you can be muted unless called upon. So it will be a very short session, and we are going to just talk about something small on programmable logic controllers and uh, try to share my screen here. So, can you see the screen?
Yes, sir.
Okay, okay. So, as earlier mentioned, we are going to see a brief introduction to programmable logic controllers, and by the end of this session, you should be able to define what programmable logic controllers are and describe the basic architecture of PLCs. So, to start with, what is a programmable logic controller? Who can tell us what they think it is? Anyone?
A programmable logic controller is an industrial computer designed for controlling manufacturing processes.
Okay, that's a good definition. So, anyone else with any other definition? So, as Samson has said, it is an industrial computer which is designed to control manufacturing processes. But if we are to define it technically, we can say that a programmable logic controller is a digital electronic device that uses programmable memory to store instructions and implement specific functioning such as programming, logic, sequence, timing, continue counting, and arithmetic operations to control electrical machines and technical processes in an industry. And some of the key features which you can derive from these definitions are ruggedized. So by ruggedized, we mean that a PLC is able to withstand some harsh industrial and environmental conditions, such as in this industry where we are using a temperature as high as 100 to 180 degrees. PLCs can withstand these temperatures compared to other controllers, microcontrollers, which can be affected by such harsh conditions as temperature. Another feature is reliability. So I guess that's self-explanatory. We can then it is easy to program, and finally, its full diagnosis process is simple, and it will be able to identify any problem with in the manufacturing process or the in the industrial process that we are controlling. So next we are going to look at the architecture of a PLC, and PLCs have three modules, which are the main modules in any general PLC. That's excluding some specialized PLCs that may have other modules, which we are not going to look at the moment. So the main three modules are the CPU module, the power supply module, and finally the input output module. So this is a basic flow diagram which shows the architecture of the PLC. We have the CPU here. This is the input module and output module, and also the power supply and the programming device, which is a peripheral device, and we don't really include on the basic architecture of the PLC, but it is essential. So CPU module. So who can tell us anything about the CPU module or what it is in maybe in not even just one word? Nicholas.
Okay, CPU module is the main module of the PLC that contain the programs. It processes and gives output, and it can also take the input.
Yeah, that's a good definition. So it says it is the I underline the word main, which I can refer to as the brain of a PLC. So a CPU, or it is the heart of a PLC system. Just like a human being, you cannot work without or you cannot survive without a heart. That's the work of a CPU. So its main function is to store and run the PLC software programs, and also helps in performing the basic arithmetic, logic, controlling, and the input-output operations specified by the instructions, which is the program. Also, it consists of three parts, I'll just mention, which are the memory, the processor, and then the power supply also comes in. Although we are going to discuss power supply. So that's the CPU module. Next is the power supply module. So a power supply module of a PLC is an essential module because there is no science that could make an electrical device, which here a PLC is an electrical device, and there is no science whatsoever which will ever make such an electrical device to work without providing any power supply to it. So every device that operates around you needs power, whether electrical or mechanical. So for a PLC, the power supply works by to convert AC, which to DC, which is will now be useful by the two other modules of the PLC. That's the CPU and the input output module. Now let's look at the this is the final module, the input output module. Anyone with who can take us through the input output module? So the input output module are these are the module that is responsible to connect the peripheral devices such as sensors and output devices such as motors. And the input output modules can be divided into two. As the digital I/O module, which we can also refer to is as a discrete module, and the analog I/O module, which can be referred to as a continuous module, just from the basic definition of digital, which is discrete, and analog, which is a continuous signal. So in a digital I/O module, the signal work on the binary system, which is 0 and 1, and which is very useful on the on and off condition. So examples of a digital I/O module are the push switch, toggle switch. There's also the limit switch. So these are basically more of sensors. Well, analog I/O modules, usually voltage is given to the input module in the form of analog signal for the analog input, and works with up to 12-bit or 13-bit signal, as compared to digital, which works only on the binary system, which is only 0 and 1. But 12-bit goes up to F, I presume. So an example of the analog IO module is the temperature transmitters, thermocouples, level transmitters, and these are the temperature detection switches and level switches, level detection, position, and so on. So up to there, we have tackled all learning out what we had planned to cover. And anyone who has a question before we can do an assignment or so. Iko swali mahali? Joanna, uko na swali?
No question.
Okay, okay, then that's good. So we'll just end by I'll give you an assignment, and it will be more of a case study. You discuss how PLC is applied in an industry of your choice. You can choose something like engine and come up with a case study. So you should be free to write anything. Case study, you can share anything, but the main thing you should cover is how PLCs have been employed, and you can come up with the merits and how it has helped in industrial revolution. So thank you for attending the class. Yeah, you can have a good day.
Good day too.